valves are on. So this is the water that goes to the condenser. That's the water that goes to the condenser, and this is the steam. Basically, this is the air that goes to the controller. So controllers are pneumatic, so we work with air instead of electricity. So that's, yeah, you can turn that on. And then this is your steam line. When you come in, you need to purge your steam for the first time. If you look at here, you have basically line here that can go either to steam or it can go to boiler. If it's in this direction, it means that we are sending the steam into the drain, and that's how we purge the steam to make sure that there is no impurity in the steam before you start. So how you turn your steam on, so first of all, make sure that this goes to the drain, and then you can open the steam, but you have to take the safety thing out, and then you can turn the steam on. Okay, now you can see the steam goes now because we are not sending it, we are sending it to the drain. Now it comes up, yes. When you hear a guzzling sound, it means that the steam is gone through the line and it has been purged. So you see the steam coming out of that. So that's one thing that you should do when you start your experiment. So that's how we purge our steam. Now we don't need our steam.
These go on.
You can turn those off too. So, and then you need also to feed your reboiler before sending the steam into the reboiler. You have to make sure that the reboiler is filled with the liquid that you want to basically use. So that's your reboiler, and you have to concentrate. So whenever you are doing experiment, you have to monitor everything, the temperature and everything continuously. So now the thing that you need to do is to measure for each experiment, you need to measure the reboiler duty and the condenser duty. There are a couple of ways that you can do it. So we have three formulas. Q is MCP delta T, and one is Q is equal to M actually heat of vaporization, and the other one is Q is equal to U delta. Okay, so if for example for this reboiler, if I want to calculate the duty of reboiler, which formula do you guys use?
Can you say that again?
So which formula do you use to calculate your reboiler duty? You have three formulas, right? So M delta H1, how can you measure your M? Which mass you are going to use? You will send the steam inside. So the steam is going to be used to boil whatever you have here. And that steam, we condense that steam and send it out here. So there is a line that the steam comes out of here. So you can basically measure the mass coming out, right? How can you now calculate the heat of vaporization? Specifically reboiler duty. So if you know how much steam is condensing, or basically you know the flow rate of the steam, how can you calculate your reboiler duty? Heat of condensing.
Yeah. Right.
Okay. So, and then that's multiplied by the mass that you're measuring. So you have to make sure that you measure this mass continuously.
Okay.
That's one way of doing it. So another way of doing the calculations for reboiler duty, if you know whenever you are everything, how can you calculate the reboiler duty?
I have no idea what you're saying.
Okay,
I can't hear you.
We are going to calculate the duty of the reboiler. How can you do that? So you already told me that one way is to use Q is equal to MH. Right? So you clarify this way. How about another way of doing it?
know the area?
You could choose MCP delta T.
MCP delta T, which temperatures you are going to use?
Well, the M would be measured using like the mass there.
Okay. And what's going to be the delta T? You are basically condensing it.
Then your delta T, would that be before and after the
So what is
reboiling?
going to be before and after if you have the steam at 100 going in and then it condenses? What is going to be the temperature coming out?
I'm sorry, what's that?
What is the temperature coming out if you send steam in and then you condense the steam? What is going to be the temperature that the steam comes out?
Whatever.
Barely below 100.
It's going to be 100, right? Because we have just doing it.
Okay, yeah.
It's just
So that's not going to help you. So how about the other formula?
The UA delta T one.
So how can you measure your area? The transfer area.
Would we
Do
have
we know it?
Would we have to estimate it by number of coils in there or not? Okay.
And the size of the coil.
Yeah. Okay.
So then you need to do an estimation of the area, and each of you can do that, and then we can compare the results,
Get an
right?
average from what we get or something like that.
Yeah.
Okay.
See.
Okay.
We don't know the like how wide the coil is.
So these are you have to estimate to do,
Okay.
do estimations.
Okay.
When you said the first time we calculate this, you said something about the enthalpy, right? Or like heat of vaporization.
Heat of vaporization was the one that you told
Okay,
me, right?
yeah.
It's the mass. So basically, we are sending steam inside. So
Yeah, that
and
makes
then we condense that steam out. So if you know the flow rate of the steam coming out,
Yeah.
condense the steam and do heat of vaporization, and HV is gonna give you
HV. Okay. What is that formula again?
MH vat,
Oh. Yeah.
M dot and H vat.
Yeah. Okay.
And then while you're writing equations down, I guess we have 3 of them total, right?
Yeah.
So
So we also have Q.
okay. Okay, you got it.
Yeah.
Okay. Okay. So what about? There are 2 delta T's in those equations. Are they the same delta T's?
No, that's a different one.
So this one
Yeah. Isn't it the
is change of temperature.
Isn't that the temperature inside the coil versus the temperature outside?
Very good. Okay, so we might write that one as IO, inside outside, right?
So that's going to be our log mean temperature difference versus an average temperature difference.
Yeah. Yeah, so technically you use log mean for that, is what you're saying? Yeah. I usually find that distinction to just be more confusing with this word. It only makes about a 10% difference. And actually calculating that log mean thing takes me a long time. So I never knew that. I just added it.
Okay. We're finishing up heat exchanger right now, so
Okay.
got
And,
that all fresh in our
class.
mind, yeah.
Okay, that's good. I'm glad you're getting that done. That means you'll be in great shape for doing this experiment.
I doubt that.
And then way more than you need to know, supposedly. Yeah, but it's different when you see it in real life. Okay, and that's what it's all about.
Yeah.
Let's see. So, I think. So, those 2 equations both relate to the reboiler heat, right? And the one thing you haven't mentioned yet is how you're going to measure the U0.
I was going to ask how we were going to measure the temperature inside and outside the coil, but yeah,
Oh,
we would
okay.
also need that as well.
All right, well, let's do the temperature inside the coil. How are you going to measure that? Or how are you going to infer that?
Alright, well, sorry, what's that? Oh, I'm just trying to figure out where the coil is.
Oh, okay.
Yeah. Well, close to. Close enough for a calculation, I guess.
What is?
Is it close enough for a calculation, I suppose?
Yeah, to what you set it to, but you're not going to be able to set the pressure. Is that? I told you.
Yeah.
You can set the pressure, you can't set the temperature.
Okay.
But you can look in your steam tables and figure out which pressure goes with which temperature. Okay.
Yeah.
Okay.
Okay.
And the good news is our pressure controllers are now working better than ever. So let's see how that works.
Yeah, we heard things were repaired this year.
Yeah, we worked very hard on that. I did a lot of yelling and screaming, and then the technician actually did the work. So that was my part. And so what we can see is that the pressure in the steam right now is pretty much zero. Just got to turn that condenser cooling on. Another thing we have to do in order for the controllers to actually work is we have to turn the air on. In a chemical plant, you don't want to use electricity a lot because it makes sparks and things go boom. So we want to use pneumatic controllers as much as possible. So right now, this is indicating that the valve is as closed as it can be. More close than it can be. -2, yeah. If we push this button, you see the white dot moved around?
Mm-hmm.
So this is saying we've got 17 inches of liquid in our reboiler. And it's measuring that by a differential pressure measurement, really. It's just weighing how much water we've got. Okay? And our set point here is 81. So if the level of the reboiler goes above 81 inches, then that valve will start to open. You'll see this thing become a positive number instead of -2. This will be up around 81. When it goes to 82, then the valve opens, then the level goes down, and then the valve closes. Okay? That whole process occurs. So, in theory, that's perfect. We're going to have the perfect level. It's going to be 81.1 100% of the time.
Yeah.
In reality, it's not like that. Okay? Our controller is a little bit lackadaisical, so it goes, 81.3, 84, 82, 81, 86. Oh my gosh, I better open. It opens the valve. 85, 84, 83, 82, 81, 79, 76. Whoa, I better close. And that whole cycle lasts about 5 minutes, maybe 10. Okay? And so if you were to measure it for 30 seconds during that cycle, you could get any number you wanted, and that would be your differential mass balance. You see how that would be not representative?
Yeah.
So you have to adapt your measurements to the reality of the operation of the valve. Okay, so you come in with certain ideas about how it's supposed to work, and then the column tells you how it really works. And then you have thought about plan A, plan B, plan C, and you instantly go to plan C. Okay? And that can happen even if you didn't anticipate everything, just the exercise of thinking about how things are working, you come in and you can adapt relatively quickly. If you just kind of show up and say, feed me, it's not going to work very well. So, all right, so right now we're getting zero pressure in there. So this is on drain, that's good. And so let's see, whoop, get up, give me a second. See your pressure gauge here? Okay. Pressure gauge here, it was like -0.5. Now we get a number, okay? If we were to close move this drain, over to the flow, and we would see that the pressure would go up again.
So
And did you talk about all these different settings? All the different thermocouple settings?
we
Yes,
were not.
Yes.
Okay,
We
good.
talked about it. We weren't all here, but
Oh, okay. Well, it'll be like that kids game. You tell them and they tell you. And then when it comes back,
Completely different than when it started.
we'll see how that final report turns out. Okay, so yeah, really good news. Okay, if you want to set that pressure, you go into set point 1 and you say enter. So you push the circle, go to set point 1, push enter, and then let's say we want to set it down to 39 or something. You gotta watch out because once it takes off, it really goes. Yeah. See what I mean? I was going for 40 there. Thought I almost had it. We don't really care. At 39.9 is good enough. Okay. And so you say enter then, and then I just keep pushing enter until it quits doing anything, and then I push the circle again until it says run, and now it's back to where I set it.
would you mind going over this again? Because I'm sharing a video of the instructions to our group.
Oh, okay. Oh, I'm on camera.
Yeah.
Okay. So this is ambient temperature. This is the reboiler temperature. Reflux splitter temperature. Tray 12, 11. Let's show it. Reboiler, reflux splitter, 12 is 3. 4 is 11. 5 is 10. 6 is 9. 7 is 8. I give up. Okay, and then 15, I think, is the cooling water temperature, which you can see is 3. And going out, it's slightly warmer because it took the heat of what's in the pipes. 3 degrees Celsius, that's cold water. Yeah, jump into that, that'd be fun. Okay, so that's pretty much the way that works. And now, first we have to turn the power on. And then we can turn our reflux splitter on. And it's currently on 6 and 2. So that means we go 6 seconds of reflux, 2 seconds of distillate. When we go up and look at the reflux splitter, you'll see how that corresponds to what's going on.
Thank you.
Alrighty. So the little mushroom over here, this is our bottom control valve. And I have to mention to you that it does not seal perfectly. And if you turn this pump on, you will drain your reboiler completely because it's not sealed perfectly. If you put any pressure on it, it's just going to drain. So we just use gravity as enough to push all the flow we need out of the reboiler. And then if you're at infinite reflux and you've got all the methanol in your column that you want, you don't want to take any bottoms out, then you want this to be closed. That will stop the flow. So this valve works fine. This one is okay for controlling if you have flow coming out, but for stopping the flow completely, not perfect. So why might you want to drain the reboiler even if you're in the infinite reflux experiment? When you fill your distillation column, you're going to have maybe a gallon of methanol in order with your 10 gallons of water to get to 10% methanol in your solution. And you've put that into the reboiler. Now you boil it. Where does the methanol go? Okay. There's about 4 inches of liquid on each tray, 9 inches in diameter. You can calculate how many trays you can fill with methanol. Do that. let's just say for now, you fill 6 trays out of 12. Okay? So then that means the bottom 6 trays don't have any more. So what's the boiling temperature in the reboiler then?
100.
100. Right? So, what do we want it to be so that something will be measurable according to our KimCAT simulations?
99, 98, 97.
98. Yeah, plus or minus 1. We'll go with that. All right. So,
Not 100.
how do we solve this problem? Should we review the problem? What's the problem?
A lot of measurable difference in temperature.
Okay, so our temperature is too high. So we want the temperature to go down. How do we make the temperature go down?
Use cooling water.
Crank up the cooling water.
What was that?
Use cooling water.
Cooling
One
water.
idea might be
or
crank
the-
up the cooling water.
Oh, okay, okay.
Does that work in the reboiler?
Let's think about
Isn't
it.
that separate from the reboiler? That's in the column, right?
All right, let's think about an analogy in our kitchen. So we've got a pot of boiling water on the stove. Okay, we put the thermometer in. What's it say?
100.
We release the pressure.
So we go turn on
You take the lid
the
off.
sink and we put the cold water, put 100% cold water. Now we go measure the temperature in the pot again. What does it say now?
100.
100 degrees.
Yeah, it's not on the
Okay, but wait.
reboiler.
We boil off some of that water. Now we've only got this much water in the pot boiling. We put the thermometer in now. What does it say?
Why do you guys want to decrease the temperature in the first place? Why do you want it to go to 98?
Infinite reflux.
So you can get the product out. So you can
So
boil.
that you can measure, right? We want that composition to be measured. You have to have enough methanol in the column that you can measure. We know that that's true when we get to 98.
Okay.
Then we're in that 2 to 3% methanol. Okay? So,
Can we just turn the reboiler off? Or are we're talking about the temperature in the reboiler, right?
well, that's
Well,
true. I mean, if
yeah.
you turn the steam off, all the contents of the column are going to come down.
And
And
crash.
if you wait around, it'll come back to room temperature. Yeah, that'll cool it down, but it's a really dull experiment.
Lower the pressure.
If you
Did you adjust the pressure?
if you introduce more of your feed stream from the column into the reboiler.
So let me sort of think through this lowering
different-
the pressure thing. So when you change the steam, this pressure of your feed, then you're changing your temperature at which the steam is condensing, right? So what's that going to change? How does the reboiler work? Q equals, we have three equations.
CP delta T.
Which one is
Or
this?
H vaporization delta T or whatever.
Yeah, delta H of vaporization.
Yeah.
Or is it the overall heat?
But you
transfer?
don't want that one.
No.
We want to control the heat input, right?
Yeah.
Which one of those is controlling the heat input? UA delta T.
Yeah.
Because you lowered the pressure. If you brought it all the way down to room temperature that it was condensing, it would be at 100 degrees C. What's the temperature in the reboiler? 100 degrees C.
Yeah.
And what's your delta T?
0. Okay.
Okay. So we control the heat input through that UA delta T. And so we would be turning down the heat input. What's the analogy of that for our hot on the stove?
Turning down the
burner.
flame.
Turn down the burner, right? You stick the thermometer in there, and it's still boiling. And what does it say?
It's still going to be 100.
100 degrees C.
Okay.
So did that help us?
I think so.
Not yet.
What are we trying to do? What's the question?
Find
We
the
need to
difference in temperature.
Change the temperature, lower the temperature.
To get to
Unmeasurable difference.
98.
Yeah, 98.
Right? So it's still 100 degrees C. Okay?
Increase your reflux.
No, we're talking about the reboiler.
We're already at
Oh.
infinite reflux.
Yeah.
Oh.
I think it's
The problem is each tray holds some liquid. We only have a finite amount of methanol we put in the column. It all went to the top trays. So we don't have any in our reboiler.
Couldn't we put like a cooler water or just pure water inside the column?
Okay, so
the
we got our
water
pot
still
of water.
boils at 100.
No, you put more cooler water inside the actual, like the more input, I guess. The cooler input, cooler feed water.
But it has
But
to
then
go through the
it's-
column.
What does a reboiler
It goes
do?
into the reboiler.
Oh, okay, it's just heating it up.
Oil.
It's gonna
So
boil.
Yeah.
we need
Sooner or later
to
it's gonna boil.
introduce methanol back into the reboiler to lower the temperature, which would
See
be
that?
lowering the reflux.
Change the temperature by changing the composition.
Yeah.
It's very indirect. Everything is very indirect. You turn the temperature down by adding methanol.
Which has a much lower boiling point.
Yeah.
So you continuously add methanol to the reboiler?
Well, that's what the feed is doing, and then you're changing your reflux rate.
If you kept adding
Your-
it forever, and this was at 10%, what would your reboiler composition be at T equals infinity? 10%. So you don't want to add it forever
So we just get it until we get a measurable amount.
until the temperature is 98, and then
Yeah.
you turn it off. Okay? So your head should be a little bit spinny right now. Okay? Oh, how do you adjust the temperature? Oh, by turning the methanol on. What? But be careful, because
Makes
if
sense.
the reboiler is already full and you start adding more methanol solution to it, and this valve is closed, and then you have a different problem. So you have to, as you're adding, you have to remove. And so a trick to that is you want to get your reboiler lever where you want it to be, then you want to go check your set point over there and adjust your set point so that it matches where you want to be. And that's up to you. Somebody else might have wanted a different set point. Somebody else, like I might have set it to a really high set point just so to make sure that people's got stuff in there and not emptying it out faster than they're putting it in. I'm going to set it to a really high value just so that we can get things rolling. Okay? So you've got to adjust your set point to make the level be what you want it to be. Okay. But don't forget about this valve.
Now, back to
I'm saying that because it has happened.
the original question was measuring the temperature inside the coils, which was the pressure setting at the front. How do we measure the temperature outside the coils?
Well, you see that thermocouple right there?
Okay, so that, yes,
That's one of our favorite thermocouples
okay.
because it's sticking right into the plug.
I didn't, okay.
And which
I go,
number
we
is
can
that
follow
over there?
that.
On the
That
dial?
was number, is reboiler, so that'd be 0 or 1.
1, right? 0 is
Yeah.
ambient.
Yeah.
Okay?
Okay.
Good, good. All right, so this is our makeup tank. And it has a little pump on the bottom of it. that sends feed up to the feed tank. So we have a feed tank at the top. We'll talk about that. Go up there and visit for a minute. Oh, this is the infamous tube that's connected to the glass that fills with liquid. And if you don't drain it properly, then you're not going to have proper indication of the composition.
Is that that's insulated tube then?
Nope.
No? Okay.
Which reminds me,
Which,
even if it's not cold outside, bring your gloves. Okay. So we have a makeup tank. This pipe here is what's coming out of where?
It's the boil.
So this is the bottoms, right?
Mhm.
So what do you think is a good name for this tank?
Bottom
Bottoms.
Bottoms.
Exactly. That's what it is. What's this one?
Something crazy like
Overhead.
bottom tank.
It doesn't come out the bottom. Where does it come out of?
it looks like the top.
Distillate. It might be called top or it might be called distillate. But either way, you can kind of figure that out. So this line is going to which tank?
Top.
Okay. And comes back here and goes here. So what might this be useful for?
Sampling
Like
that
that
line.
Sampling.
Sampling the distillate, or just collect all of it in a graduated cylinder if you've got a few hundred cc's. And what's that flow rate supposed to be? How many cc's per minute? According to our first ChemiCAD simulation.
Wasn't about 1 or something like that?
No.
Per minute?
Is it like 44 or something?
48.
48,
Okay,
yep.
right? Okay.
Yeah, 44 was our heat transfer coefficient.
1 cc per second. Okay. So we could just constantly watch that, and then whenever we're ready to take a sample, pour a little off. And then we've got a reasonable differential mass balance that's integrated over 5 or 10 minutes, right? If we don't overflow it in 5 or 10 minutes, then we've got a good overall. It might have flowed a little bit, then it didn't flow, and it flowed a little bit, then it flowed. Over that 5-minute period, we've got a good sample of all those cycles.
So, Dr. Elliott,
Yep.
when you say we should measure our concentrations at the beginning in order to do the integration,
And our levels.
our levels in.
So,
How much is in the tank?
Oh, okay. So we can say how much we
and here, and here.
Okay.
So we know how much is going out.
And generally what I do is I just take this bucket and I hang it from here. But you gotta weigh the bucket first.
Okay.
Okay? And then you can just hang it from here, and then you'll know exactly how much stuff you have. However